Assalamualaikum. Today I will present my final year project. My title for this project are Development of Drone Navigation System for Fertilizing Durian Tree. Okay, my name is Syarafina Solehah Binti Salehuddin. My matric number B0118100064. My supervisor name is Dr. Muhammad Khairi bin Muhammad Nur. Before I present in more detail, I will explain a bit about background for my project. First, drone is one of the technology used to increase quantity and quality of agriculture product. Second, to adapt drone technology for smart durian farming, it should have a system that can navigate autonomously to avoid natural obstacles such as tree, branches and leaves, while on the same time can do fertilizing tasks for durian tree. This is my problem statement and objective. Problem statement. Durian trees, especially from leaf growth stage until durian trees preparation for flowering stage, require proper care and foliar fertilizer in the right quantity, referring to the frequency of fertilization each month. Moreover, at this stage, only 50% of durian trees will survive if not fertilized properly. Drone is an unmanned aerial vehicle used to help optimize agriculture operation, increase crop production and monitor crop growth. Because of that, to facilitate the fertilization durian trees and reduce worker fatigue, drone can solve this problem. Objective. The objective of the project are as follows. First, to study the application of agriculture drone. Second, to propose proper spraying method on durian trees. And third, to analyze navigation system. Next is scope and limitation. First, only study on navigation strategy for fertilizer around tree and assume no wind indoor. Second, to no real fertilizer carried during simulation. Objective achieved. For Objective 1, to study the application of agriculture drone, and Objective 2, to propose proper spraying method on durian trees, I have achieved in PSM 1. For PSM 2, this semester I focus on Objective 3, which are to analyze navigation system. From figure 3.14 is the appropriate distance between trees, which are 10 meter, and figure 3.14 is the appropriate distance between the trees and the sprayer drone, which are 4 meter. Planning algorithm to find a motion plan and avoid the obstacles set are detected during navigation. I will present project in sampling based algorithm for optimal motion planning (RRT star). RRT star enable real-time navigation in dynamic environment. Example, in environment with obstacle that unpredictably appear and it will move. RRT star will update the remodels a single graph and its shortest path subtree over the entire duration of navigation. Before I explain my result, I will explain in more detail why I choose this method. Assalamualaikum, Syarafina here. Today I will talk about the difference between random tree, RRT and RRT star, sampling based algorithm for optimal motion. Okay, first kali random tree. Random forestry (RFT) is a machine-based decision-making system. Random tree (RT) belongs to a machine learning approach that classifies the assemble. The word assemble involves a strategy which predicts comparing multiple different baseline models with their projection. Random forests are composed of multiple independent decision trees that are trained independently on a random subset of data. Okay, it means it randomly sample data point and variable in each of the tree that it creates and then combine the output at the end. It removes the bias that the decision tree model might introduce in the system. Okay, here we can see the difference between random tree, RRT and RRT star. Okay, obstacle type. Okay, first none. Second sparse like this. Okay, next narrow passage. Okay, and last concave. This is for obstacle from start to goal. Okay, number of nodes to add, we have 1, 10, 100, 200 and 500. Okay, first we try with narrow passage. Okay, for exploring bias, we pick random. Okay, 0.05. Okay, for goal radius, this is for the radius of the endpoint area. So we pick random. Okay. Okay, we can also determine where the endpoint is located to see the journey of the drone from the start to the endpoint. Okay, from the start to the endpoint. Okay, first we start with the random tree method to see the final result using this method. First, we will add the number of nodes to see the random tree. Okay, 1, add another one, add another one. Okay, we can see with the concept of random tree, he will cluster it because it randomly sample data point and variables in each of the tree that it creates and then is combined the output at the end. It removes the bias that the decision tree model might introduce in the system. Also, it improves the predictive power significantly. But it is not an appropriate decision because the point is not moving towards the endpoint. Okay, we try add another 100 nodes to add, but we can see it clustered in one place only. Okay, next we try using RRT method. Okay, we add one node. Okay, add another 10 node to be faster. Add another 100 nodes. Okay, from the diagram with 12 nodes, goals did not reach. We will add nodes until we reach the endpoint. It's okay, we try to add another 100 nodes. Finally, we get the endpoint as well. Okay, from the diagram with 212 nodes, we get path length 41. Okay, next we try with RRT star. We will do the same way for RRT star method. To speed up, we will continue to top up high nodes. We will see the difference with the previous method. So we try to add another 100 nodes until we get to the endpoint. Finally, we get the result. Okay, with 212 nodes, path length is 31.76. We can see the difference between using RRT and RRT star. For RRT method, with 212 nodes, we get 41 for the path length. Next, with RRT star, not same as the test for RRT, but we get 31.76 and also straighter compared to the RRT method. This is the result of using sampling-based algorithm for optimal motion planning (RRT star) in MATLAB. From the diagram above, we can see that the black color is an obstacle that must be passed by the drone starting from coordinate 2, 1 and heading to the endpoint which is 12, 10. Next, a red line to show the route travelled by the drone from the start point to the end point. Furthermore, the blue line is the result of using RRT star as the way to avoid obstacles along the way. The total distance is 10 meters. That is the distance between the three. Nowadays, the RRT algorithm is one of the most popular path planning method for UAV delivery. Although the search of RRT is fast, the planned path is generally not be the optimal path. The improved RRT star algorithm improve the way. However, sampling-based path planning algorithm RRT star obtain the information of obstacle in the environment through collision detection of sampling point. They avoid the problem of direct description of space and can be better solved to path planning problem of UAV in high dimension space or under complex constraints. The basic idea of RRT algorithm is to form a random tree by random sampling in the search space. We need to find the node closest to the sampling point on the random tree and then intercept a specific step in the direction to the sampling point as the new node and perform collision detection. If there is no collision, we add the new node to the random tree. By repeating the operation above, we can quickly search the free space until getting a collision-free path from the initial point to the target point. This result to show diagram more large and complicated map. From the diagram above, we can see that the black color is the obstacle that must be passed by the drone starting from the coordinate 3, 3 and heading to the endpoint which is 45, 35. Next, the red line in the diagram is to show the route travelled by the drone from the start point to the end point. Furthermore, the blue line is the result of using RRT star as the way to avoid obstacle along the way. Adalah bentuk halangan atau obstacle dalam bentuk 3D. From this diagram, we can see that the red point is the starting point, which is coordinate 50, 154, and the green point is the end point, which is coordinate 150, 154. This is distance between 10 trees. We can see that the improved RRT star algorithm completes the planning with the least number of extended nodes, the shorter path length, and the least search time in the simulation process of randomly distributed obstacle 3D map, which is in line with the expected experimental result. Sample-based path planning algorithms such as probabilistic roadmap (PRM) and random tree (RRT) have shown successful and contain theoretical safeguards such as the probabilistic exhaustively, but the formal quality examination of the answer given by the such algorithm, for example based on number of samples, have been devoted little effort. New methods, specifically sample-based algorithms for optimal motion planning (RRT star), were introduced, which are proven to be asymptotically optimal such that the cost of the return solution nearly certain covers to optimum. From the picture above, we can see the difference between using sampling-based algorithm for optimal motion planning (RRT star) and rapidly exploring random tree (RRT). As we can see in the picture, there are different values for the path length for the two methods. The first picture is the decision make using a 212 nodes and get 41 for the path length using rapidly explore random tree (RRT). Next, the second image is the result of using sampling-based algorithm for optimal motion planning (RRT star), which is with 212 nodes, same as the test for RRT, but get 31.76 for path length. This has proved that using RRT star can reduce the length of the road, and the line is also straighter compared to the RRT method. RRT star are uniform sampling decrease the likelihood of nodes being selected from the short passage. Just a few approaches to the problem of finding the best way across narrow passage have been published. Conclusion. We can see that the RRT star algorithm completes the planning with the least number of extended nodes, the shorter path length, and the least search time in the simulation process of randomly distributed obstacle 3D map. In the navigation environment, road planning for an unmanned aerial vehicle guarantees that the dynamically possible and collision-free path is planned between a start and an end point. That's all from me. Thank you. Assalamualaikum.